So a little bit about me. I do not have a software education in my background. In fact, my first job out of college was systems engineering that involved hardware and software. When I started working for software companies about 30 years ago, I thought that that was a liability. I actually think that this has been an asset for me in the organizations that I've run over the last 30 years. A little bit about my current company. I started a company about 15 years ago called Don't Panic Labs. We are currently about 55 people. We service mostly small startups and established companies doing new innovation development, new product development, and product reinvention. We do about 10 to 20 projects a year, which is a lot. So some of these are smaller projects, some of them are larger, but it gives us a lot of iterations with a lot of different companies, a lot of different business domains, and working with a lot of different teams as we integrate with those teams. So in my subtitle of my talk, I talked about maintaining a constant pace indefinitely. What I mean by that is that it's kind of like the holy grail for people who are working on software and businesses. They want to build a product and continue to evolve that product over time and not lose velocity. And I will tell you, this is a key frustration of stakeholders and software developers themselves, this inability to kind of maintain that constant pace indefinitely, especially after a few years of development. So software systems are obviously gotten a lot more complex. So if you look at it from my perspective, when I first got into this industry back in '95, we were building desktop applications. We were building business knowledge worker systems that were running on Microsoft Access. This whole client-server thing was kind of emerging at the time. The problems we were solving were very simple. Some applications were being developed by individual developers. And in fact, back then in the 90s, I rarely worked with anybody who had an education in computer science. Most people were self-taught. They got into that industry because oftentimes they were in a different role in that industry and started picking up software as something they liked to do. People discovered they could build them tools that could help them do their job better, and all of a sudden they became software developers. Today, when we formed our company in 2010, we had already advanced in terms of the type of problems we're trying to solve, let alone the hosting environments we're trying to host these applications in. We have not hired anybody since 2010. That's probably 100 engineers or so over that period of time who didn't have some formal background in computer science or software engineering. It's really difficult for somebody who's self-taught these days to get even their foot in the door with an organization. And I think that speaks to the complexity of the problems we're trying to solve as well. A lot of organizations, whether they admit it or not, the positive outcomes of their efforts are often relying more on hope than any sort of disciplined, rigorous process that could give them some sort of a predictable outcome. And one of the things I've come to realize is that there are many outcomes that we're looking for, whether they're small efforts that are being done by developers or whether they're business objectives we're trying to accomplish within the software, that we're really leaving that positive, predictable outcome to chance. We're relying very heavily on individual developers making good judgments all the time and doing the right thing, or relying on their intelligence and smarts, which is pretty risky and frankly doesn't always work out well. So I want to highlight a few things here today, hopefully give you some food for thought. Are some of the things that I've kind of identified as kind of some of these core challenges that a lot of these organizations that we work with face. And maybe first and foremost is this notion of errors in judgment. And you don't hear people talking about this a lot. In engineering, we talked about it a lot in terms of errors in judgment. That's usually where the problems are coming in. It's not like people are intentionally making bad judgment calls. They're always trying to do the right thing, right? People are trying to make, whether I'm designing an API or writing a test or doing testing or decomposing the system, I'm not just winging, I'm not just saying, it doesn't matter, maybe I'll just kind of do a crappy job. They're trying to do a good job. But oftentimes that's where the problems start with these applications being able to kind of live a long life and be productive and maintain that constant pace indefinitely. And there's three things that are contributing to that, right? They lack the experience, right? So I'm probably not going to make the same errors of judgment today that I made when I was 25. And you can't really that's something difficult to kind of overcome, right? Experience is something that's difficult to teach. But we're also lacking knowledge, and we don't really have good processes to detect when errors and judgments might be occurring. And so I'll address a couple of those things when I talk about some of the things we could probably be doing. But this errors and judgment thing, I would love to see more for the academics in the room. I think there's really a lot that could be done to try to help to identify when people are likely to make poor judgments, or maybe creating what are the right processes and tools that might help people identify when their judgment might be suspect. And there are, in industry, things are not black and white. It's shades of gray. So I realize this is a very difficult problem to solve, but nevertheless, it could really be beneficial to everyone. Excessive coupling. This should come as no surprise to anyone. Most systems die a slow death because they have not effectively managed the level of coupling within the system. Cloud services that a lot of our applications are being hosted now create a number of great tools, what we call knobs and dials, that actually help us promote better coupling, more looser coupling within our systems. But still, going back to this errors and judgment, individuals are having a hard time really balancing the trade-offs of what level of coupling they should have. It's very difficult for them to understand the decisions they're making today, the impact that might have down the road. And I would suggest that that's not something that can't be solved. Right? Again, I think that a lot of that has to do with the tools that we have, the knowledge that we have around that. It's not good enough just to understand what coupling is. You have to be effective in terms of how do you evaluate and make a judgment call on the level of coupling you have. A classic example I see quite a bit is developers will often increase the level of data coupling in APIs unnecessarily to try to avoid an additional round trip to the database or something like that. So let's say I've got this data, I should just pass it to this other method and this other service rather than having to go get it, not realizing that they're kind of exposing information about that service within that call. It's something that you understand why they do it, but they're not really thinking about it in terms of the long-term impact of that. Design stamina. This is one of my favorite topics because this speaks directly to the ability of systems to be able to evolve over time without kind of bogging down and slowing down. Oftentimes when you build a new system, that first system looks very rational. It looks really good, really easy to understand. It's well thought out. But over time, like any system, entropy will find its way in through a lot of different ways, right? Individual decisions that people are making, it's death by 1,000 cuts, right? And companies struggle to kind of maintain that conceptual integrity over time. And to make matters worse, a lot of systems don't look like they were designed by one person. They look like they were designed by the number of people who actually worked on that system, which is not ideal. Right? Martin Fowler spoke about this about 17 years ago. He's one of the authors of the Agile Manifesto. He had this notion of design stamina, like how valuable is good design. In achieving design stamina is not just something that you do once and then you move on. It is good design and conceptual integrity is something that has to be nurtured throughout a system. So a lot of organizations, they have people who are in this architecture role, for example, and they do the architecture for this application and then they move on, and leaving the conceptual integrity of that architecture to these individuals who are making these daily judgment calls. Another one is effective state management. It used to be fairly simple fairly straightforward to build these client-server applications we were building in the 90s and early 2000s. Now the way that we can store state, the structure of that data, how it's distributed, the amount of coupling that happens between the data models that are in the database and what's happening in the UI front-end layer, it's very difficult, I think, for us to really manage that effectively, let alone things like transactions, things that were fairly routine when you were working with a relational database system like Oracle SQL Server, become really much more difficult when you're working in a cloud distributed system. And finally, this whole idea of achieving acceptable quality. So I think one thing that's good is I think that there is an increased demand for quality in the software we're using today. A lot of that, we see that most visibly in user experience and interactions. A lot of applications survive based upon that user experience. And users are fairly intolerant of systems that don't kind of meet their threshold of quality. But I think that it's still a monumental effort for organizations to kind of achieve that level of quality. And if you look statistically at the amount of time they spend on corrective maintenance, on average, they're probably spending 50% of their time. So half of their workforce is doing nothing but fixing bugs or recovering from poor requirements or ineffective design. So those are kind of the core issues I see in the organizations that we work with and some of the challenges. So I'll spend the rest of this talking a little bit about some of the things that I think we need to be focusing on to try to address some of these things. Keeping in mind that I think our goal should be in industry is that we don't rely on what I would call virtuoso performance, like some individual rock star that is the reason that we got this product over the finish line and that it was successful. That we should be able to address all of our, all of our software projects should be, the norm would be that they get a successful outcome, which means the quality that's expected, the timeline, the budget, all the constraints that businesses have, by using what I would call average engineers. So folks like myself and the people in my company and the people who are in the industry. That should be our goal. That's the goal of the other engineering disciplines, whether you're civil engineering, electrical engineering. I would like to see us get to that point where it's like, hey, these problems, it's going to be rare where a project suffers for a lack of budget or timeline or gets canceled. So that's really kind of what I think the ultimate goal should be for our industry. So number one in trying to address these challenges is I really think we need to invest in the development of software and systems engineering literacy and competency. I think students leaving school should not just be aware of these concepts, but should be armed with mental models of what it means to develop modern systems. So that they're not kind of coming into their first job and just overwhelmed. Yeah, they may understand the coding constructs and things like that, but oftentimes they're overwhelmed by just the whole process and all the different roles that are involved in building software, and all the considerations around design and testing, all the critical thought that has to be done around that to do these trade-offs in a world of gray. I would love to see students coming out armed with some set of tools and understanding of what it takes to what's necessary to do that. Not that they're going to be able to work autonomously, but companies are going to have to invest less time in just trying to get them to plug into whatever processes they have. A lot of these errors in judgment, what we've tried to do is we've tried to identify point-in-time critical questions to ask of individuals at particular times to try to get them to think more deeply about the decisions they're making in the hopes that will reduce errors in judgment. We have found anecdotally that helps tremendously, right? We've created guardrails as much as we can to kind of prevent that. I think education can do a lot to kind of help both develop these types of tools and critical thinking exercises and then arm these students with them when they come out. Adopt systems that effectively apply information hiding principles. It was a pretty influential paper I read by David Parnas that was written in the early 70s. You're probably all aware of it, but most people, the vast majority of people in the industry wouldn't have any idea what the principle of information hiding is. But it is, I believe, in a service-oriented world like we're in, is a core driving principle for how we decompose systems. And especially in terms of stamina, the whole idea is we're going to encapsulate likely volatility in the system within components and modules that are going to be easy to change, rather than every new change that comes into a system is spread throughout the entire code base, which is the norm. And that's what contributes to a lot of the lack of design stamina. So I would love to see students come out of school knowing how to decompose systems into services using some of these principles and not just kind of randomly selecting services based upon functionality or something like that. Identifying accountability for ensuring process and conceptual integrity. Like I said, a lot of organizations have roles for certain things, like the people are responsible for detailed design or architecture, things like that. But they don't follow through as much to ensure that those things survive ongoing modifications to the system. And again, entropy is a real thing within software systems, and it's death by 1,000 cuts, and it requires this constant nurturing. Institutionalizing quality. So this is something I think, with the advent of tools that make it so much easier to write automated tests, some of this has happened. But I think that being deliberate about quality practices that happen even when we're analyzing the requirements and breaking down stories and thinking about how we might be able to kind of reduce uncertainty, getting stakeholders to write Gherkin-style syntax requirements that makes it much easier for developers to kind of both understand the requirement but develop tests for that. Things like that. There is no silver bullet for quality in a system. It has to be a layered approach. And we heard a lot about AI today, or this week, and you can't hardly read any news without seeing something about AI. But I feel like there's a lot of focus with the AI tools on being a code buddy, and I feel like where it could really benefit people, especially in an environment where we have so many people in industry that lack basics, literacy in things beyond just coding, that these AI tools could be potential coaches or mentors or teachers that could be sitting beside them and helping them, helping identify opportunities to kind of question their judgment or present alternative ideas or to give a set of checklists of things they ought to be considering based upon the context of the work they're trying to do. I would love to see that be kind of an emphasis as opposed to help me write this code or something like that. So maybe we'll see more advances there as well. And then finally, this is happening whether people like it or not. Back in the day, everything was kind of we were marrying state and logic in everything we were building back in the early 90s and early 2000s. But with everybody trying to push things to the cloud, it almost invites you to build more stateless or state-aware services. And I think that, again, that's another tool for managing the amount of coupling within the system. But what I've also found, having overseen the development of dozens of systems over the last 15 years that fall into these categories, it's much easier for developers to reason about these types of systems. When you separate when you separate just business logic within these stateless or state-aware services and remove the state from that, and if you decompose it based upon something other than just functionality, developers have less of a difficulty in just trying to understand how the system works and how to evaluate the impact of changes that they're having to make through a system. So I think that there's all kinds of other benefits to stateless and state-aware systems in terms of scalability and deployability and things like that on the DevOps side. But I think just from developers being able to reason about a system and develop a mental model of that system, I think they're incredibly valuable for that. All right, so that's what I have, 19 minutes. So I encourage you, if I've said something that you disagree with or that you'd like to learn more about, I encourage you to reach out to me. I do try to be a little provocative in some of my presentations, but what I'm really trying to do is to get people to maybe think a little bit differently about kind of what's going on out there and what are some of the challenges that still exist. So thank you.